Hi, thank you all for coming. I'm Jim D'Amato. This is Pete Oliver Kruger. Say hi, Pete.
Hi, Pete.
Hi, Pete.
Yeah.
All right. We are here to talk today about what we're calling Industrialization Driven Development. The whole crux of this is we want to get to market faster. So how do we do it? Well, let's find out. A little bit of agenda here. We will talk a little bit about what hardware is like, talk a little bit about the concept of industrialization, and then the way that we began to apply these techniques to speed up the process of industrialization. And then if there's more time at the end, we'll talk about why hardware is kind of a funny environment to operate in. All right, so I already sort of said, I'm Jim D'Amato. I am a transformation lead with Eliason Group. We're one of the sponsors. Happily, we got our presentation accepted before Eliason became a sponsor, so I think it was organic. I think. Pete, go ahead.
Yeah, so I'm Pete Oliver Kruger, and I'm an author. If you want to find out more about putting human at the center of what you do, you can check out my book, Shifting People, Shift from Product to People. But I'm doing a lot of stuff across the years, and started off as electrical engineering, which got me, I think, partially into this gig here. Done a lot of stuff with software, did things with Lean Startup, and so now we're back to manufacturing.
All right, and not here is Abele Okachar. She has been our partner in crime through all of this. She is a tremendous colleague. She lives in Atlanta. Not possible for her to come, but she's been a full contributor to all of this. So, all right. Just a little bit of demographics here. Who here has any sort of tangential connection to working with or building physical devices? Cyber-physical, hardware, physical devices. Who has connection to that?
Does past work?
Yes.
Okay.
Okay. All right. What brought you to this one? I mean, there's 3 other presentations. What brought you to this one? By the way, bullet point brevity.
I used to be heavily into robotics and manufacturing, and I have also applied Agile in some hardware spaces.
Come on in.
That's what you guys do.
All right. What brought you to this one as opposed to the other 3?
I know Pete, I figured it would be a good presentation.
All right, there you go.
Oh, thank you.
All right. Man, what about you? What brought you here?
Well, I'm actually here with a few of my colleagues, and we're dividing and conquering. And so I'm the lucky one to come here.
Was this the short straw or was this the long straw?
No comment.
No comment. We have the keynote here. Hi. Yeah.
Yes, he did a good job yesterday telling me that this is a place where I need to be. So.
All right. There you go.
I appreciate you listening.
There you go. Let's see. One more. Ma'am, you gave me your name earlier, but Jenna. What made you came to this one today? Okay. All right.
There's always something to take from.
There's always something to take. I completely agree. Pete, any more questions you want to ask to get some demographics from our audience?
Yes, curious as far as, well, branching off of that, anybody here worked with software but in a manufacturing context? Okay, that's sort of the thing. All right. If it was firmware, put your hand up. If it was software, if you don't know the difference, then it wasn't firmware. Okay. All right, and who here has DevOps experience? Because we're going to talk about some DevOps terms. Okay, all right. So we got some familiarity. Fantastic. Anything else I forget? No.
And we were talking earlier, program management. I think the crux of this will speak to anybody who's doing program management, because what we sort of essentially did was took a scope of work and delivered the same scope of work in a shorter amount of time. Which I think any program manager would go, oh, that's wonderful. All right. Anything else?
No, go for it.
Move on. So, This is sort of hardware, working in agility and hardware has been sort of a difficult experience. There are things about hardware that just are harder. And when you're virtual or you're digital or you're simulated, everything can go quickly, almost just about as quickly as any sort of regular software development, because, hey, you're keeping it all digital, right? But the moment you go physical, everything slows down. Almost painfully so, right? There are a whole host of, and this is super simplified. There's a whole host of domain areas that are involved, and we're sort of trying to highlight here that all of those domains are really involved. The technical stack can be dizzying. All right. So before we get too far, though, right? So we're here to talk about industrialization. Before we get too far, okay, let me define actually what industrialization is, because when I started, I didn't necessarily know. I'm not much for reading slides. Industrialization, the comprehensive process of moving. Oh, screw it. You're going for scale. All right, in engineering, in your product development, you can make 1, 2, 10, 20, heck, maybe you can make 100. When you're going to go to market, when you need to sell a lot, you're going to make 1,000, 100,000, 1,000,000. And there is infrastructure you need to be able to make that happen. Physical infrastructure, all right? And borrowing a quote that generally gets applied to Tesla, it is building the machine that builds the machine. So, okay, great. We know that engineering is about building the machine or building the product, and industrialization is about sort of a little bit of a meta concept, building the machine that builds the machine. What we realized is we had a whole host of challenges. The goal here, the reason they brought us in, was to figure out how to get this thing done faster, right? I mean, I'll borrow a phrase. The thing that sort of always resonated for me was, you know, imagine if, this is a software analogy, imagine if you had to build a custom compiler for every software application you ever wrote. Oh, and by the way, it took you a year or more. I mean, that's madness. It's madness. And this is what hardware organizations have to do. You get to code freeze, you get to design freeze, you have to wait a year. What? That's crazy. So we had to figure out how to improve time to market. The organization that we started working with, they had produced lots and lots of timelines, and every timeline started to slip, and there was just no trust left. So how do we fix that? There are myriad suppliers. One of the things that Tesla did really, really well is they brought a lot of stuff in-house. This organization does not do that. They outsourced everything. And imagine if every one of your database tables had its own separate vendor. That's madness. And yet, in hardware, it's real, okay? And aside from a few consultants, we're not spending any money to fix anything. Okay, got it. Let's see what we can do here, all right? I had an opportunity early in my career to work with a guy named Joe Justice. Anybody know who Joe Justice is? A couple? You know Joe? Yeah, Joe's all over Europe. Yeah. He loves to travel. He's everywhere. So I got to work with Joe, and I'll always remember a time we're leaving New York City. on a train up to Tarrytown, New York, and we're on the train, we're going to a medical device manufacturer, and he lays a knowledge bomb on me. Jim, Agile doesn't change in hardware. Blew my mind. But it's true. Agile doesn't change. Oh, sure, the constraints are a little different. Oh, sure, you have to figure out how to make the key work in this hole. But Agile itself doesn't change. Maybe we sort of get a little bit creative. Maybe we're sort of recognizing that there needs to be flexibility to make this stuff work. But Agile as a concept, as a mindset, doesn't change. We've got tools in the toolbox. All right? So, what we realized was, we're just going to do the things that we know work. All right? Because we didn't, I mean, I'm a software guy and I was consulting for a hardware organization. Pete at least has an electrical engineering degree. I'm a software guy. What am I doing? I was not seduced that hardware was different. Somebody laughed at that. I appreciate you. Well, I spouted that all over the place. No, hardware's not different. Yes, it is. No, it's not. All right. All right, a little bit more first. Oh, sorry. What we sort of began to do was to find the model in our head that we knew we could work with. All right. And eventually, I came up with this slogan that hardware is just really slow software. And Pete's like, could you phrase that just a little less pejoratively? How about hardware is software in slow motion? Great, Pete, done. Great. I don't know, I was feeling a little snarky that day. But this is sort of the mindset that we have. And so what you're going to hear us talk a lot about today are things, mindsets, tools, techniques that come through DevOps. All right. Oh, did you need that?
Oh, thanks. Okay, I got it. Thank you.
You got it? All right. All right, so a little bit more about industrialization. Frozen design. Great, let's build it. Oh, we don't have anything to build it on. That's where a whole lot of stuff begins to come in the middle. I'm sorry, the font's small. I tried to actually extend this all out into one long line because that's really essentially what it is. It's one long line, and then it would have been really small on the screen. All right. But what you begin to realize is once you've frozen the design, you need to go through a whole lot of procurement. Who thinks procurement is slow? Okay. That's a trick question to get people to raise your hands. Procurement's slow, and then you've got to go and find people who can actually do the things that you want. You need molds. Sometimes you need molds, sometimes you need a lot of molds because you need molds to make parts, and all of this stuff starts to stretch out. And you have to know the parts to know how to tell the robots what they're going to use. And these are not Tesla-style robots that are super flexible. They have opposable joints. No. These are, they lean the heck out of this stuff. Also, you can eventually build your line, run your line, build your product, and customers have product that they can buy. All right?
Yeah, the fewer the joints, the cheaper the robot.
So, Pete's going to talk about the principles that we used, right? We're trying to get back to this idea, because it was the only one that I could cling to, is we know the things that work. So let's use that.
All right.
15 minutes.
So, working backwards from the future, we know this somewhat in terms of DevOps, Kanban, a lot of the work. I use this a lot in architecture. When I was first getting started, I ran through a couple different versions of things. Like at the beginning, I was taught the big upfront design everybody else does. So I did big upfront design. And then there's a lot of time that's spent. That's what these people were doing right now, already getting started. Then I got clued into just-in-time work, and so I started doing things just in time. And as an idea would come up, I would design it and work it, and then as the project went along, oh, we forgot this. Oh, we didn't plan about this. Oh, we did. And all it did was delay the work to the end of the project. And so it became, instead of big upfront design, it was big at the end design, or redesign, refactoring. And so this was a thing that I came upon to look forward into the future, or go forward to the future, think of where you are, look backwards and what you need to get there, but then selectively choose what you're going to develop at which stage. So you know that you might need to branch off into place, but so there's a couple things baked into this, but that is working backwards from the future. We'll get into that in a little bit more detail. The other principle that we did up here at the front was going to be looking at process maps and cross-functional teams. Sneak preview, cross-functional teams are possible in manufacturing, but they don't realize it until you get into it. So let's take a look at some of the stuff that we were talking about. All right, so we're you guys have all been here. I'm not gonna spend a lot of time on this as far as a push versus pull kind of a system, but most of the time push goes through. They're doing a lot of push in the manufacturing space. And of course, if you find something at the end, then you have a loop, you have to go back, you have to fix it, and you have to adjust it. This can be super expensive when it comes to a manufacturing kind of a context, as well as software. So of course, in DevOps, we decided to go backwards and work from the end. And say, all right, so we've got a test, it's built to the test-driven development, we'll put all that stuff together, and then we send it to the PO, and they're like, that's not what I asked for. I'm like, oh, we should bring the PO into this, acceptance test-driven development. So we write the test with the PO first to make sure it's going to pass, and then we write our test TDD scripts to go with it, and that pulls that into acceptance test-driven development. Now, in software, we would move on to BDD, which would be going directly to the customer and working with use cases. But for a bunch of these products, they had one use case, maybe two, for a 3-year project. So it didn't make sense to them to work backwards from a direct use case or a direct customer case in many of these things. So we gave them something else to think about, which is the factory. So we could produce something that the product wants and the team knows how to, the engineers know how to do, but the factory can't build it. So let's think backwards from what the factory needs, put all this stuff together, figure out how we're going to verify it inside of the factory. Then we can work with the product owner, then we can work with our test-driven stuff. And so we put all this stuff together. That was what, then we needed a new name for it because it kind of didn't exist as far as we know. So we called it Industrialization Driven Development. So that's IDD. So you saw this before, very waterfall, right? This is what their Gantt charts look like. This is what it was based upon these resources where they had here's the engineers that we need, here's when procurement people are going to come involved, here's when the factory people are going to come involved. They didn't even hire the people to do this until after the engineering was done. So they had no sense of cross-functional for this reason. We said, let's do DevOps thinking, because Agile is Agile. And we sat down and said, all right, so tell us, let's work backwards from the very end and tell us what you do. All right, so somebody goes into a store and buys our thing or something. So yeah, we got like a hardware store. They go to Home Depot or a Lowe's or Ace Hardware and buy this product. Or they have an electrical contractor who says, okay, here's the product I'm going to install for you. Either way, it's going to come from some kind of a wholesaler. So that's really all we really had to pay attention to. And we went backwards from there and said, all right, well, what happens next? Well, they're going to order it from the factory. Okay, so to have that, we have to then spin up an assembly line. And the quality people were like, wait, but first we have to verify that assembly line. It's not just building an assembly line. If we're going backwards, everything has to be verified before we do it. So then we build the assembly line, and we have to design the assembly line. Now, you may notice some of the things here. You're interacting with the customer at the end. You've got a design process that happens. You got a build process that happens. You got a quality process that happens in order to do a delivery process. So this is all kind of pretty standard to software, except that, well, I'm going back to, let me show you another piece here. Okay, so there's more to it, and they looked at the assembly line. They said, all right, to build the assembly line, we need to build a robot that's going to do a bunch of these different things. As you can see, this one doesn't have a lot of joints, so this one makes it a lot cheaper. So, but we went through and figured out this actually is a testing robot. And so this came up about, what do we do as far as a qualifying testing process? They honestly kind of laugh at us a little bit when we say, oh, we're going to go build our automated test, and we sit down at a computer and type some stuff. They're like, oh, I had to go get the electrical, I had to go order some parts, I had to build this machine, I have to get some welding in here and pull out my soldering iron. But like that, their testers are full-fledged engineers who build robots that test the parts. That's one of the huge biggest differences between software and hardware, is just the amount of work that has to go into every single step that we do. Procurement goes into there. So these are all parts that are in here. Now you may start to recognize that we can very easily do test first design. We're already doing it. There are these processes in there called FMEA and FAIR that were a test-driven development kind of process where they're defining the parameters of how it should work before they start working on building it, because they needed it for procurement. They couldn't do procurement if they didn't know what the procedure was. So, what does it take to build a robot? Same thing. Same steps of process. So now you're seeing the iterative process that's going in here, but one of the lines we worked on had 3 robots, and each robot had 9 parts. So now you're taking all the work, the standard iterations, but you're multiplying it by 3 and multiplying it by 9. I'm going to skip the molded parts and go back and look at engineering. Every single one of those parts, 3 times 9, also has a design process, but that is a standard iteration in an Agile context, but getting to that part. So when you put it all together, it looks kind of like this. And this is one of the super simple manufacturing processes in this. So when we took these things and mapped it out and put it in front of you, first off, the project manager was like, oh my God, for the first time in the world, the thing in my head, everybody else can see. Now do you guys understand why I'm freaking out and you're not? Like, you know that you need to get this part done here with the robot, but I know that everything else on here has to happen to get those parts together so that you can get the thing that you need to build the robot. People, you gotta get moving. We are wasting too much time. So that was one of the big differences. So the mapping makes a difference. Remember, this was what they were originally working on, so this was how they allocated people and how they allocated resources. This was what was actually happening, and as you can see, very cross-functional. All over the place, but they needed to see it. Once they did this, we were able to get them to establish a team up front that had every single part, because they were like, oh, we're never going to use the factory people for now. We're like, no, factory people are going to give feedback in the daily stand-ups while the engineers are talking about what their new designs were, and they're like, oh God, you're wasting our time. And then they spent so much time talking, you can't do that. Wait, that's going to be really hard to build. Oh, can you make this different? And then they started to realize that the daily stand-up actually had a reason. All right, roadmaps is the next major thing that we built in, and getting into some of this iterative work. So we took the same thing and we laid it out on a timeline and said, all right, well, that wholesale distribution thing, how long does that take? It takes us about 4 weeks. Mass production takes about 4 weeks to run that up. To put the production line takes about 4 weeks to get that done. And we started turning that workflow diagram into a sense of time. And we ended up doing something like this. This is one of the first passes that we did. And we started from the beginning with the engineering and kind of laid this out. You'll notice that I say, do not do this, because they were really thinking from what do I have to do next, and they weren't really thinking about the future. To do that, well, we'll figure it out as we get there. But we took TDD, ATDD, DevOps principles and said, no, let's work backwards. So we started over again and said, okay, let's lay this out on the production line. What's our riskiest, biggest problem that we have to face? Let's tackle that first, figure out. And they had one robot, the supplier was back ordered. There was one company that could order that could build it. So they were just stuck waiting. Most of that time was waiting to get into the queue, and then they built the robot right here in the last 2 weeks. So, but you don't want to keep a supplier waiting. So it's like get everything ready together. So it pulls together with the iterations. We unrolled some iterations. So this is basically 3 iterations worth, just to give us sort of an average time of how long it might take to figure out a part. We found out that like if you line these things up and the engineers where they're working, and we could actually fit the second part while we're waiting for the other thing to happen. Looked at a couple more of these things, realized that we could fit the whole second robot while we were waiting for the first one, but we had to get procurement out the door by that date to get in the queue. And if they didn't have procurement, if they didn't have the contract, they weren't in the queue, and we didn't start the clock. So we had to develop parts off of that, figure those together, and we realized that we could fit the other one inside of that as well. So that became one of our rules. So we go back to this one. So this was our original timeline. So here's what it compares with when we did it backwards. We saved them 6 months in execution by working backwards. Exact same work, but in a different order, saved time without an extra cost.
Because they were working on the right things at the right time.
Right things at the right time, exactly.
They knew what was critical path.
Exactly. Yeah, we for the first time gave them a really true critical path that they could trace all the way through. Which gets us down to this thing about how do we execute on this. So we've got time boxes, these are other things we do. Iterative execution, what does that look like? We needed them to be able to own this one. So while we built this first with the leads to know what was going on, we then handed it over to them. And this was our sprint planning. So we got a thing. This is what you need to do in these 2 weeks. If you don't get everything in this column done in 2 weeks, tell us because we're off track and we need to redesign or we need to replan something out. And we did that multiple times and we found new ways to bring the timeline in, but we were realistic. This was PI planning. If it's outside of this box, do not do it. That was really hard. People were like, oh, here's a part. Oh, I got this thing done. Oh, you should take a look at this. Nope. Is it in the box? No, it's not in the box. But somebody really wants me to do it. Go talk to the project manager. We'll give them. It's like empowering the Scrum Master, the same way that we do, or empowering the product owner to set the scope of things. So one of the things that we started with is they said, we can't trust this team. No matter what they do, they're always late. Their estimates are completely wrong. And we got them to an 85% predictability. So pretty much whatever they promised they were going to do within the course of a couple of weeks or a couple of months, they were pretty much there, exception of like maybe 10% or so.
There was, if I might, Pete, there was a lot that went into that first bullet. One of the things that you get with hardware versus software, in software we have full stack developers. They know every layer of the tech stack. In hardware, you have people that specialize in a particular slice of that tech stack for their entire career. And they don't want to do anything else. And so what happens is you have a specialization. Specializations create bottlenecks. I don't need one of this person on every team, so you end up getting sliced across teams. You, in essence, are a service desk, right? And then all of a sudden, the one team needs you, but you're working on another team, and well, hey, wait a minute, it becomes impossible for the team to meet their commitments. So getting them to actually have an 85% predictability was profound.
Yeah. The cross-functional sort of like T-shaped kind of doesn't exist. Let me take that, I said that wrong. What I meant to say was M-shaped does not exist. Because the person who did this had a PhD. The person who did this had a master's. The person who had this has a master's in different fields. So to be M-shaped, you'd have to go back to school for at least 2 to 4 more years to become M-shaped. But what they could do was T-shaped, which is in my job that I know really, really well. I know what I need from the person in front of me. So like maybe I'm in the middle here building the robot or putting that together. I know what the engineering person does, so I can help them with their engineering tasks. I can't do their engineering tasks, but there's certain things that we can communicate with. I know what the procurement person does, so I can help them with procurement. I know what the testing person does, so I can help them with figuring out their testing robot. And I know what the factory does to implement this stuff, so I can go in and I can help and I advise. I can maybe help build some stuff and put them things together, help with ordering. So you can help out another thing without having to have another degree in that. So T-shaping is possible inside of. All right, now I'm skipping around here. I got to this point and I was like, I'm saying a lot of things. I kind of like to take a pause and hear any questions. Anybody have some thoughts? Anybody have any questions that they want to take?
What's M-shape?
Huh?
What's M-shape?
Oh, okay. It comes from the, if you know one thing really well, you're like sort of the silo, you only know your one thing. The T-shaped was said that, if I can go in depth in one skill, but I can go across multiple skills within that team and help out with a variety of other different activities, even though that's not my job. And then M-shape said I could learn to go deep in a few different things. So in software, it's like I might be a programmer, and I use my programming skills to learn how to code tests. And I might learn how to work with a customer, and so now I can go out and do customer testing as well. And so I could learn in depth in all these different things. But one of the things that we hadn't paid a lot of attention to was that it kind of was the same thing. Like you were doing some programming, you were doing some other things in some other categories, but it was all software, maybe just a slightly different language or a slightly different platform. And it didn't require going back and doing years and years and degrees of schooling and defending a thesis in order to be able to extend the M.
I wanted to ask you a question really about when you unlocked the time to market improvement by focusing on the constraint of the one robotic supplier.
Yeah.
We thought of full rapid period constraints, so I was just wondering if
Yes.
you guys mind that set of knowledge and maybe even critical chain project management to solve some of this, or were you just kind of purely focused on Agile DevOps principles?
We were all over the place. We pulled everything in the toolbox that we could think of to do that. So yeah, I'm a big fan of theory of constraints. So I did that, and I actually started them off with some of you a few years back might have done the Agile card. I have an Agile card game where I teach the Agile principles just with a deck of cards to prove that it has nothing to do with software. It just has to do with how we work, and I introduce theories of constraints through that to show that when you start changing how you think, and they go from sorting a deck of cards, which takes them like 15 minutes, which they can't get done, to everybody in the entire room sorting the deck of cards in less than 1 minute, and they're just competing on how fast they can do it, just by changing the process, nothing else.
Pete, can you go back to the schedule view?
Yeah, I can now because I found the remote. I lost
There
it.
we go.
This one or the larger one?
Keep going. All right, so you mentioned theory of constraints. So has anybody read The Goal? Okay. One of the key teachings in The Goal is don't let your bottleneck go idle. And we realized that all of the suppliers had a funny little quirk that if they were receiving work from you, they would do it as quickly as they could. However, if they weren't receiving work from you, they would go on to something else. And you might not get them back for weeks or months. And so we started to realize the worst thing that you could do was to not have something ready for your supplier. Keep them on your account. Don't let that bottleneck go idle.
Yeah.
Theory of constraints. We pulled everything out of the toolbox for this.
And they had that usual false belief that, oh, well, if we just give the specs to the suppliers, they can just build it. No, you're going to iterate with your suppliers, but you can't make the iteration your fault. It has to be their discovery.
So you've got a shorter time frame, and you optimize time to market, not engineering. What turned out like, it seems like there's gotta be a trade-off where something increased or changed or decreased.
The iron triangle, right?
Not so much the iron triangle, but, you know, did utilization go down, or did some other characteristic of the system change? Because they were optimizing for something, which was engineering. Now they're getting better time to market. What does it mean to not optimize for engineering?
They optimized for the end.
You're not going to believe me when I say this, but we made all of those things better. We were faster, we were cheaper, people were happier, they collaborated more. They, every single one of those things, like we were locked into the iron triangle, we thought, and then we blew the iron triangle out. There are certain things that maybe we couldn't move. Like sometimes if we were optimizing for speed, we couldn't at the same time reduce the costs. So we might have to hold one thing in, but it wasn't that the other thing went up. We could hold time steady and lower cost. And then we could lower cost and reduce time. And because it really was these concepts of theory of constraints and a bunch of these other things, which take the same number of people, the same amount of effort, just change the sequencing and the approach of how we do the work so that we are not wasting time. It was very Kanban as well. It's all about muda and waste and finding all that stuff and getting rid of all those different wastes. And so you can achieve a lot more by focused on waste. And the map and the timeline helps you find the waste faster before we get there. All right, so we got through this. So we were just going to wrap into this. Did you want to do the?
Oh, yeah, sure. You know, just to sort of bring this all home, the crux of this is sort of like I said before, and I used to have these really great intellectual debates with hardware engineers. Hardware's not different. Yes, it is. No, it's not. All right.
It is and it isn't.
It takes some adjustment in how you think.
Yeah.
But the crux of hardware is that if you're thinking about how to speed it up, and that's what all of us are here to do, is to learn ways to speed things up. You get a business book, you devour the business book, you add it to your toolbox, you're like, all right, I got new things to try, right? It's all the same. And what we did here is we focused on DevOps. So, you know, Pete showed some of this stuff. This is some of the sort of conceptual comparisons. You know, hardware takes an order of magnitude maybe more than software to do. The ability to pivot, to go back and change in hardware, nobody wants to do it. They want to do it once.
Yeah, the idea of automating your DevOps line in software is we update the software, we come up with some automation things. To automate a line in hardware, they do that, and it's called a robot. And you have to design a robot, and you have to determine the parts, and you have to build a robot, and you've got to put all this stuff in together. That's how you get production speed takeoff, but it's a physical process, not a software process.
One of the challenges with the idea of flexible robots, this company thrived on their margin.
Yeah.
So every extra dollar that they put in was a dollar that they were not going to earn in profit. So they really tried to keep it lean, and they didn't want to change. Once you meet regulatory approval, great, we're selling that for 30 years, done. We kept thinking through the comparisons, hardware to software, and it worked for us. We didn't necessarily tell them that this is what we were doing. We just kept going through the mental gymnastics, all right? We kept going through it. All the way back to, all the way back to engineering. You know, product development, I think, is sort of largely solved in any case, in any sense. Hardware, software. And we thought about this as just another product development. It's the product that builds the product. Let's skip over some. Pete, I lost it.
Oh, you lost it? Sorry.
Skip over the. There we go. Back to this. Hold on. All right,
Yeah.
wrapping up here. I think we got 45 seconds. If this is something that interests you, this is the shameless plug. If something like this, whether it's hardware or software, the idea of speeding up time to market, right? The crux of it was that we worked backwards to resequence, and it was enormously powerful. If you want to learn how to do this, if you would just like a lunch and learn, all right? We're here, we can do it, we can share this. We feel like we've innovated. We were really, really excited to do this. We feel like we innovated on something. If you would like to reach out to us, we are here. I'll be a booth babe at the Eliason booth with my other booth babe colleague, Bob Fisher here. Hi, Bob. We are here to talk about this. We'll be at the happy hour. I'm easy to find, just look up. All right? And that's it. Thank you.